Hi, my name is Nandita Srikumar, and my project is the effect of curcumin and epigallotic 3 gallate on the biomarkers of Alzheimer's disease. So before diving in deeper, here's a brief introduction about myself. I'm a rising junior at Solon High School, and I'm from Solon, Ohio in the United States. Some of the extracurriculars that I do at school include speech and debate, FBLA, and FPS. Apart from school, I'm also a student researcher at Case Western Reserve University, and this is the research that I'll be presenting to you today. Additionally, I'm also an active volunteer at the university hospitals for the past 2 years, and I'm also a Bharatanatyam dancer and a Carnatic vocalist. I hope to pursue neuroscience in the future. So, what is Alzheimer's disease? Alzheimer's disease is a neurodegenerative disorder that causes the degeneration of the brain over time. And unfortunately, it is currently defined as an incurable disease. This incurable disease affects over 55 million people worldwide. And this number is projected to increase to over 130 million cases by the year of 2030, making it a global health crisis that is imperative to solve. So, what is the characterization of Alzheimer's and what defines it at the molecular level? In a healthy brain, both tau and the CRIM2 protein help to stabilize the internal microtubules of the neuronal cells, which are parts of the cells that help to provide stabilization for the neuronal cell structure. But in an Alzheimer's disease brain, the cyclin dependent kinase 5, or also known as CDK5 kinase, hyperphosphorylates both CRIM2 and the tau protein, or in other words, adds multiple phosphate groups. This hyperphosphorylated tau and CRIM2 is unable to regulate the neurons, which eventually leads to the destabilization of the neurons. In the long run, oligomers or clumps of both tau and CRIM2 are formed, eventually leading to the formation of neurofibrillary tangles. These fibril tangles can eventually lead to the loss of synaptic communication between the neurons as they begin to not be able to communicate with each other. Currently, Alzheimer's is defined as an incurable disease, but new research has shown potential with both curcumin and epigallotic 3 gallate, or short as EGCG. Curcumin is a polyphenolic compound found within turmeric, while EGCG is a polyphenolic compound found within green tea. Both of these compounds have shown through research that it can help to prevent tau aggregation and the hyperphosphorylation of CDK5, proving to have potential and success within the Alzheimer's disease field. While many studies have only conducted populational studies, my research today aims to show it at a molecular level. Next, moving on to the methodology behind my experiments, I used microscale thermophoresis, or also known as MST. MST is a process by which that uses infrared laser lights to create microscopic changes within the temperature. These changes within the temperature allow changes within the proteins, which is detected by the MST to understand various binding affinity patterns, or also known as the strength of the binding between the proteins. Using this process, I conducted a series of baseline testings. The main and most prominent baseline testing that I conducted was between CRIMP2, active CDK5, and the tau protein. The combination of these three proteins within this test allowed me to understand that there was a significant binding between these proteins, once again helping to reestablish the fact that these proteins help to play a large role in the development of Alzheimer's disease. Next, moving on to my experimental testing, the first testing that I did in this process was between CRIMP2, active CDK5, tau, and EGCG. In this test, I found that there was a higher KD value compared to the baseline testing, which helps to suggest a lower affinity between the proteins. So I created a model to represent on how this may work at the molecular basis. In this model, both CRIM2 and CDK5 have high affinity with each other, but with the addition of EGCG, the affinity between these two proteins significantly decreases, suggesting that EGCG may be binding either with CDK5 or CRIM2 in a competitive manner, or may be binding with one of the proteins to create a conformational shape change. Although this model only represents CRIM2 and CDK5, it can also be changed to represent tau in the model as well. The next experimental test that I did was between CRIM2, active CDK5, tau, and curcumin. Unlike my EGCG test, this test showed a lower KD value, which suggests higher binding between the proteins. Once again, I created another molecular model to represent on how this may work. First, the CRIM2 and the CDK5 have high affinity with each other, but with the addition of curcumin, the affinity between these proteins significantly increases, suggesting that curcumin may also be able to create a conformational shape change, helping to increase the binding between the proteins. In conclusion, I was able to understand that the EGCG helps to decrease binding and interaction between the proteins, helping to suggest that the EGCG may be competitively binding with the proteins or helping to create a conformational shape change, potentially helping to reduce fibril formation. On the other hand, my results from curcumin are far different from what I originally expected. I originally expected that the curcumin would present similar results to EGCG, but instead, the addition of curcumin, in fact, increased the binding affinity between the proteins. One potential reason for this result could have been due to the bright yellow color that curcumin presents in its natural form, which could have potentially skewed the MST results. This can easily be fixed in the future by doing additional testing with different instruments and processes. These are my references and works cited. I'd like to thank the Global Health Leader Conference for giving me the opportunity to present my research, and thank you so much for taking the time to listen today. Most importantly, this project would not have been made possible without the continuous guidance and support from Dr. Buck at the Buck Lab and also Ms. Maria Ayanachi, who helped to give me guidance and support throughout my project. And finally, thank you so much to my parents, my family, and my teachers at Solon High School. Thank you so much for listening today, and if you have any further questions, please feel free to contact me either via my email or my LinkedIn. Thank you.